Good day viewers, welcome to another biology presentation. So in this presentation we are going to look at the multiple choice questions on enzymes. So we are just going to answer from question 1 up to question 20. So let's look at the questions. So here is our question 1. What are enzymes primarily made of? A. Carbohydrates, B. Lipids, C. Nucleic acids, D. Proteins. So enzymes are primarily made of what? Proteins. So here we are saying enzymes are proteins. So the correct answer is a D. So we now move on to question 2. Enzymes function as dash. A. Biological catalyst, B. Energy sources, C. Structural components, D. Genetic materials. So enzymes function as the biological catalyst. So the correct answer here is A. We now move on to question 3. So question 3 reads, the active site of an enzyme is dash. A. The region where the enzyme binds to the substrate, B. The entire enzyme molecule, C. The product of the enzymatic reaction, D. The cofactor required for enzyme activity. So the active site of an enzyme is just the region where the enzyme binds to the substrate. So the correct answer here is A. So we have answered our question 1 to 3. We now move on to the next question. Our question 4 reads, the Michaelis-Menten equation describes A. The rate of an enzyme catalyzed reaction, B. The structure of an enzyme, C. The activation energy of a reaction, D. The pH optimum of an enzyme. So here we want to find out the Michaelis-Menten equation, what it describes. So this equation just describes the rate of an enzyme catalyzed what? Reaction. So the correct answer here is A. So we now come to question 5. The question reads, a competitive inhibitor dash A binds to the active site of an enzyme, B changes the enzyme's shape, C binds to a site on the enzyme other than the active site, D increases the enzyme's activity. Okay, so here we are looking at a competitive inhibitor. So a competitive inhibitor simply means it's an inhibitor that binds to the active site of an enzyme. So a competitive inhibitor binds to the active site of an enzyme. So the correct answer here on 5 is A. So we now move on to question 6. Question 6 reads, which of the following factors can affect enzyme activity? A. Temperature, B. pH, D. Substrate concentration, D. All of the above. So here we are looking at the factors that can affect the enzyme activity, and you know that the activity of an enzyme can be affected by temperature, pH, substrate concentration. So meaning that all these that are listed, they can affect the activity of an enzyme. So the correct answer is D, which is all of the above. So we move on to our question 7. So our question 7 reads, a non-competitive inhibitor dash A binds to the active site of an enzyme, B changes the enzyme's shape, C binds to a site on the enzyme other than the active site, D increases the enzyme's activity. So we are looking at a non-competitive inhibitor. So a non-competitive inhibitor just binds to a site on the enzyme other than the active site. So the correct answer here is a C. So we come to question 7. Question 8. Question 8 reads, amylase is an enzyme that breaks down dash A. Proteins, B. Fats, C. Carbohydrates, D. Nucleic acids. So amylase is an enzyme that primarily breaks down carbohydrates, specifically starch. Okay, so the correct answer here is a C. So we now move on to our question 9. Lipase catalyzes the hydrolysis of dash A. Proteins, B. Fats, C. Carbohydrates, D. Nucleic acids. So when you look at lipase enzyme, this one catalyzes the hydrolysis of fats or lipids. So the correct answer here is C, a B. So we have answered our question 9. We now move on to question 10. Our question 10 reads, which enzyme is involved in DNA replication? A. DNA polymerase, B. RNA polymerase, C. helicase, D. ligase. So the enzyme that is involved in DNA replication is the enzyme known as the DNA polymerase. So the correct answer here is C, A. So we now move on to our question 11. Our question 11 reads, the primary function of enzymes is to dash. A. Provide energy for cellular processes, B. Store genetic information, C. Catalyze chemical reaction, D. Transport substances across all cell membranes. So here we are looking at the primary function of an enzyme, which is just to catalyze chemical reactions. So the correct answer here is a C. So we move on to the next question. So here is our question 12. Our question 12 reads, enzymes increase the rate of a chemical reaction by dash. A. Increasing the activation energy, B. Decreasing the activation energy, C. Increasing the temperature, D. Decreasing the pH. So here we are looking at how enzymes are able to increase the rate of a chemical reaction. Okay, so enzymes are able to increase the rate of a chemical reaction by decreasing the activation energy. So our correct answer here is a B. So we now move on to our next question. So here is our question 13. Our question 13 reads, the specificity of an enzyme is determined by dash. A. The shape of its active site, B. The temperature at which it works, C. The pH at which it works, D. The presence of cofactors. So here we understand that we have one characteristic of enzymes where we say enzymes are specific. So what is the specificity of an enzyme? What determines that? Okay, so the specificity of an enzyme is determined by the shape of the active site. So here our correct answer is A. We now move on to our question 14. So here is our question 14. Our question 14 reads, enzymes can be denatured by dash. A. High temperatures, B. Extreme pH, C. Both A and B, D. Neither A nor B. So enzymes can be denatured or enzymes can be destroyed by both high temperature and the extreme pH. So the correct answer here is C, both A and B. So C is our correct answer. Both high temperature and high pH can destroy the enzyme. We now move on to our next question. So here is our question 15. Our question 15 reads, cofactors are dash. A. Inorganic molecules that help enzymes function, B. Organic molecules that help enzymes function, C. Proteins that help enzymes function, D. Nucleic acids that help enzymes function. So what are cofactors? So when you look at cofactors, we are simply looking at inorganic molecules that help the enzymes to be able to carry out their functions. So our correct answer here is A. So we have answered our question 15. We now move on to our next question. So here we come to question 16. Our question 16 reads, what happens to enzyme activity as temperature increases? What happens to enzyme activity as temperature increases? So when the temperature increases, you find that what will happen to the activity of an enzyme is that it's going to increase as well until it reaches an optimum temperature. So when it reaches an optimum temperature, this enzyme is not going to go beyond that. If the temperature becomes too high, you find that the activity of the enzyme is going to be denatured or destroyed. So here our correct answer is B. So what will happen the activity of an enzyme as temperature increases is that it's also going to increase until it reaches an optimum what temperature. So we have answered our question 16. We now move on to our next question. So here is our question 17. Our question 17 reads, why does enzyme activity decrease at very high temperatures? So they want us to state why the enzyme activity decreases at very high temperatures. So here you find that the enzyme activity is going to decrease at a very high temperature because the enzyme's active site is going to be destroyed, just like I'm just from explaining. So here our correct answer is B. The enzyme's active site is destroyed, okay, if we have the high temperature. Okay, so we have answered our question 17. We now move on to our next question. So here is our question 18. Our question 18 reads, each enzyme has an optimum pH at which it works best. What happens to enzyme activity when the pH deviates from the optimum? So what is going to happen to the enzyme activity when the pH deviates from the optimum? First of all, we know that the optimum pH, this is the pH at which the enzymes works best. Okay, so if the enzymes deviates from the optimum pH, what is going to happen to that enzyme is that the activity of that enzyme is going to decrease. So the correct answer here on 18, it's C, it's a B. So we have answered our question 18. We now move on to our question 19. Our question 19 reads, why does a change in pH affect enzyme activity? So they want us to state why a change in the pH will affect the enzyme activity. So the change in the pH will affect the enzyme activity because it changes the shape, meaning it changes the shape of the active site. So our correct answer here is C, it's a B. It changes the shape of the enzyme's active site. So we now move on to our last question, and this is our question 20. Our question 20 reads, which of the following factors can affect both enzyme activity and the rate of a chemical reaction? A, temperature, B, pH, C, substrate concentration. So here temperature can affect both enzyme activity and the rate of a chemical reaction. pH will also can affect both enzyme activity and the rate of a chemical reaction. Substrate concentration can also affect both enzyme activity and the rate of a chemical reaction. So you can see that all these factors can affect both enzyme activity and the rate of a chemical reaction. So the correct answer here is C, a D, which is the all of the above. So this is our answer. So thank you so much for having time to view this content. We've come to the end of our session. This has been your presenter, Mr. Mlenga. Bye bye.